When it comes to trigonometry, the trig ratios are actually going to be pretty important to figure out lengths of sides and angles. So when it comes to trig, what it really is the study of the properties of triangles. And we're dealing with angle measurements. Trig ratios are nothing more than comparing the lengths of two sides of a right triangle. So anytime we have a right triangle, it's possible to use trig. If we don't have a right triangle, either we have to create a right triangle in order to use trig, or we just can't use it. So as long as we have a right triangle, we can deal with sine, cosine, and tangent. Now the question becomes, what are sine, cosine, and tangent related to? Well, all we have to remember is the acronym SOHCAHTOA. So SOHCAHTOA. So sine, cosine, and tangent. So sine is going to be equal to the opposite side over the hypotenuse. Cosine is going to be equal to the adjacent side over the hypotenuse. And the tangent is going to equal the opposite side over the adjacent side. So the hypotenuse is always going to be across from the right angle. And then opposite and adjacent sides are going to be dependent on what angle we're dealing with. So for instance, here in our little box here, we're dealing with the sine, cosine, and tangent of angle A. So there is angle A. So sine being opposite over hypotenuse, the opposite side is the one across from it. So in this case, it's going to be A. So side A over the hypotenuse side C. Cosine A, cosine is adjacent, so the one right next to it. In this case, it's going to be side B over side C, adjacent over hypotenuse. And then tangent is opposite over the adjacent side B. So we're going to use that in order to figure out the ratio and measurements in simplest form. So we need to find the sine, cosine, and tangent of the following angles. So angle P is our first one. So we have to figure out the sine, cosine, and tangent for angle P. So sine of angle P is opposite over hypotenuse. So opposite would be 7. Over the hypotenuse across from the right angle, 25. Cosine of angle P is the adjacent side. So in this case, it's 24. Over our hypotenuse, 25. And then tangent of angle P is opposite 7 over the adjacent, 24. Angle N is what we have to find next. So there's angle N. So sine of angle N is opposite over hypotenuse, 24 over 25. Cosine of angle N is adjacent over hypotenuse. So the adjacent would be 7, and the hypotenuse is 25. Tangent is opposite over adjacent, so the tangent of angle N, opposite is 24 over adjacent 7. So notice the relationship between the two angles that are not the right angle. So if I look at angle P versus angle N, notice sine of angle P is the same as cosine of angle N. Cosine of angle P is the same as sine of N. And then the tangents are inverses of each other. And we can use that to our advantage later on. To find the value to the nearest 10,000th. So again, 10,000th, typically we do 4 decimal places. So sine, we need to find the sine, cosine, and tangent of these different angles. Now, when it comes to tangent, when it comes to trig, there are actually two different formats that we can deal with in terms of math. We can either deal with degrees or we can deal with radians. So anytime we're dealing with degree, we want to make sure our calculator is in the appropriate mode. So to figure out which mode we're in, we just hit the mode button. On the third line down, notice we can switch between radian and degree. Because we're dealing with degrees of a triangle, we want to make sure that degree is the one being highlighted. So we'll just go scroll over to degree and hit enter on it. So now that it's flashing. So we'll quit here and go back. All we have to do is hit sine 42, and it gives us what sine of 42 is equal to the nearest 10,000. So 0.66913, we just round, so it'll be 0.6691. And we do the same thing for cosine and tangent. So cosine 65 gives us 0.4226. And then we do the tangent of 78. Gives us 4.7046. So again, make sure the calculator is in degree mode when we are dealing with degrees, which in this case we are, and we'll get the value of each. And we can use ratios to find our missing measurements. So for instance, here we have triangle ABC. Here we're told we have an angle of 36, missing side of x, and a hypotenuse of 21. And again, I know that's the hypotenuse because it's across from the right angle. So we're not going to, whenever it comes to the trig ratios, we're not going to deal with the right angle. We're going to be dealing with the non-right angle bit. So here we are told we have an angle of 36 degrees. And we want to look at the relationship between the sides. So x is across, so there's our opposite. 21 we've already said is the hypotenuse. So we have opposite and hypotenuse. Therefore, I can say sine. Sine is opposite over hypotenuse. So we have the sine of our angle measurement, 36, is equal to our side ratios. Opposite is x over 21. And again, we're solving for x. So how do I do that? Well, I want to get x by itself. Here we're dividing by 21. So we'll multiply by 21 to cancel out. And we'll do it to both sides. So the 21s will cancel out. So what I have here is 21 times sine of 36. So that's all we'll do. 21 times the sine of 36 gives us 12.3434903. So we'll just round to the nearest tenth, so 12.3 equals x. Here we have in letter B an angle measurement of 53. We have x, which is opposite, it's across from it, and then 32 is across from the right angle, so there's our hypotenuse. So again, the trig ratio we're dealing with, opposite over hypotenuse, would be sine. So we have the sine of our angle measure, 53, is equal to x over 32. And again, I'm going to solve the same way. I'm dividing by 32. I want x by itself, so we'll multiply both sides by 32. So what that does is it cancels on this side, leaving me with just x. And then we'll multiply this in our calculator. 32 times sine 53. Rounding to the nearest tenth means we have 25.6 for a value of x. And we can do the same thing for C and D using trig ratios. We can also use trig ratios when it comes to word problems. Leaning Tower of Pisa has a 5.2 degree tilt. if it's 55 meters tall, how far have we shifted from the original position? So here we're told we have an angle measurement of 5.2 degrees. What are the relationships of the sides? Well, x is across from it, so there's our opposite. Right angle, so this means A to C is our hypotenuse, the long side, which leaves 55 as the adjacent side. So we have opposite and adjacent, meaning we're going to be dealing with tangent. So the tangent of 5.2 is equal to x over 55, opposite over adjacent. So solve for x, we just multiply both sides by 55. And we get x equals 5. So how far have we shifted? We have shifted, according to our problem, 5 meters. And again, we can do it for the same word problems. Number 5, I'll do number 5, and then the rest we can do individually. So from a point 120 meters away, Serena measures the angle between the ground and the top of the building, finding it to be 41 degrees. How tall is the building? So here we have 120, right angle. So right angle across from the right angle would be our hypotenuse. Meaning y, in this case, doesn't matter if it's on both sides. There's our y, so there's opposite from 41 degree, which means 120 is going to be our adjacent. So opposite and adjacent, meaning again, we're dealing with tangent. So tangent, in our case of 41 degrees, is equal to y, opposite, over our adjacent, 120. So to figure it out, 120 is multiplied on both sides. So we are left with y is equal to 104.3 meters. And if, according to rounding, it would be 104 once we round it. And that is using angle measurements in trig ratios.